Welcome students, हम डिस्कस कर रहे हैं the 12th numerical from the exercise for the chapter mechanical properties of solids. So let's start. Now the question says what is the stress in a wire which is 50 meters long and 0.01 centimeter square in its cross section if the wire bears a load of 100 kilograms. Now let's try to understand this story with a diagram now. So सबसे पहले let us draw a rigid support. So this can be a ceiling or a stand, we don't care. And इस rigid support से there is a long wire that is hanging. Now इस wire का length let us represent using the capital letter L. So capital letter L marks the length of the wire, and then there's a one more property जो हमें दिया है question में, that is the cross sectional area. So wire is a three-dimensional object and it is in cylindrical shape, and इस cylinder का जो हमें cross sectional area है that is given to us, and we represent that area using the capital letter A. And then आगे question में बताया गया है कि what if इस wire का जो free end है इसे हमने एक लोड के साथ कनेक्ट कर दिया. लोड इज जस्ट अ फैंसी लैंग्वेज ऑफ सेइंग सम मास. ठीक है, एंड इस लोड का मास इज गिवन टू अस. लेट अस रिप्रेजेंट इट यूजिंग द कैपिटल लेटर m. Now, since we attach this load to a wire, and of course, because this load has some mass, it will experience a downward force, that is the weight of this load, and this weight is mass times its gravitational force. And because of this load, हमारा जो wire है that will also experience a downward force. Because of this, our wire will go under some stress, and that stress is what we have to calculate in our given question. So let's try to quickly calculate that stress. So the given quantities are, first is the length of the wire, that is capital L, it's said to be 50 meters. Second quantity that's given to us is the cross-sectional area, given to us as 0.01 centimeter square. But keep in mind, we have a conflict over here. Centimeter square is not an SI unit, so अब conversion करना पड़ेगा. So 0.01 centimeter square becomes 0.01 into 10 raised to minus 4 meter square. A simple conversion. ठीक है. Third quantity जो हमें दिया है, that is the mass of the load, and we represent this mass using the capital letter M, and this mass is said to be 100 kilograms. इसके अलावा और कोई quantity दिया है? Well, no. Now let's move on to find section. क्या ढूंढना है? And हमने पहले ही discuss किया है, हमें stress ढूंढना है. Stress in what? Stress in wire. So we have a task to calculate the stress in the wire. But what sort of stress is this? Because last time हमने check किया था, stress came in two flavors. एक was the shearing stress and the other was the longitudinal stress. Well, if you see, अगर हम हमारे वायर के bottom most part पे अगर फोकस करेंगे, so कुछ ये वाले पार्ट पे, तो इसका कुछ ऐसा क्रॉस सेक्शनल एरिया होगा, एंड इस पे जो है डाउनवर्ड डायरेक्शन में एक फोर्स लग रहा है, एंड दिस फोर्स इज नाउ परपेंडिकुलर टू द एरिया ऑफ द वायर. एंड व्हेनेवर वी स्पीक ऑफ अ परपेंडिकुलर फोर्स, हमें पता है कि वी आर टॉकिंग अबाउट लॉन्गिट्यूडनल स्ट्रेस. दैट्स राइट. वैसे इस गिवन क्वेश्चन में इट वाज नॉट दैट इंपॉर्टेंट टू क्लासिफाई द स्ट्रेस, बट इट्स ऑलवेज necessary to understand the basics. So we are calculating the longitudinal stress, and let's try to understand what sort of formulas we can use to calculate this longitudinal stress. So the first formula, that is the formula for longitudinal stress, is given to us as the perpendicular force divided by the cross sectional area. Longitudinal stress है, इसके लिए force perpendicular होना necessary है, and in our case this force is the weight of the load, that is mass time gravitational acceleration divided by the cross sectional area of the wire. Now if you see, सारे quantities, that is the M and the A and the G, are already pre-given quantities in our given section. So a simple substitution will fetch us the value for stress. So what are we waiting for? Let's try to calculate it. So calculation section में हमारा first statement, that is from formula 1. So from formula 1, we can calculate the value for stress. So stress in our wire is given as mass, which is 100 kilograms, into G, that is 9.8, commonly known value, divided by the cross-sectional area, that is 0.01 into 10 raised to minus 4 meter square. Now, let's simplify this calculation. 9.8 into 100 can be written as 9.8 into 10 raised to 2. and 0.01 into 10 raised to minus 4 effectively becomes 10 raised to minus 6. Now, if we calculate this further, if we were to multiply by 10 raised to 6 and divide by 10 raised to 6 simultaneously to this term, then हमारे पास effective term would be 9.8 into 10 raised to 2 into 10 raised to 6, that is 10 raised to 2 plus 6, 10 raised to 8 divided by 1, because 10 raised to minus 6 into 10 raised to 6 effectively cancels out each other and gives us 1. So final value of our stress, that is the stress in our wire, is 9.8 into 10 raised to 8 newtons per meter square. Very, very important. That is the units for quantities. So this is our final answer. That is the stress, which is 9.8 into 10 raised to 8 Newton meter square. So final statement can be the stress in the wire is 9.8 into 10 raised to 8 Newton meter square. Link for the PDF of the solution is available in the description. So make sure you check that out as well. Have a nice day.